Notes are for section 5 of chapter 5 in geometry, and we're going to talk about trapezoids. So just right in it, a trapezoid is a quadrilateral with at least one pair of opposite sides that are parallel. So I believe your trapezoid's already labeled, but the parts, we got two bases, top and bottom are both bases. The sides that are not parallel are called your legs. The midpoints of those legs could be connected with a median. Otherwise, you have four base angles. All right, so if I switch colors here, actually I meant to. Right, this angle, this angle, this angle, and this angle, none of which have to be congruent right now because this is not a isosceles trapezoid, so that'll happen here in a second, but all of those are just considered base angles. All right, so then median has a definition. It's this segment joining, joining midpoints of the legs. And then that brings us into our first theorem, right? The median of a trapezoid. And there are 2 points to this. So A, it is parallel to the bases. B, it's going to be half, so is half the length of the sum of the bases. All right, so if I had a trapezoid, if I just draw one quickly here, right, and I know that the top is 10, the bottom base is 30. If I had a median connecting the midpoints in here, right, if I add the two bases and get 40, divide by 2, that would give me my length of my median. It'd be 20 in this case. Now, some of you would recognize that that is actually an average of those two bases, right, in terms of an equation. When I'm adding two numbers and dividing by 2, that gives me an average. So it's the average length of those bases, if you want to think about it that way. Otherwise, we do have isosceles triangles that have their own special things. So we're going to define that here. That's a quad. Sorry, I need a Q, not a G there. With one pair, opposite sides parallel, and the other pair is congruent. Otherwise, there's two theorems for that. My base angles in an isosceles triangle isosceles trapezoid are congruent. The diagonals of an isosceles trapezoid are also congruent. So again, if I had an isosceles trapezoid, that would mean that these two lengths, the two legs, are congruent to each other. So that means that these base angles here and here would be congruent. The top two base angles are also congruent, but they're not congruent to the bottom ones. They are supplementary to the bottom ones because you have parallel sides here and here. But otherwise, base angles the corresponding base angles are going to be congruent. And then the diagonals of an isosceles trapezoid are also congruent. So if I connect my diagonals, they don't bisect each other, but they do happen to be congruent. All right, so that takes us to some examples over here. So we're going to solve for x in all these different situations. And again, remember, you average 30 and 12 to get x. So 30 plus 12 divided by 2, that's going to give me my x, which happens to be 21 in this case. On my next one, again, you need to know kind of an equation for this. I can add my bases, divide by 2, but I can also think about it this way. So it was 4x, right? When I combine those two x's, minus 4. I could divide that by 2, and would it give me 22? But I have one of two options. I can either say 2x minus 2 equals 22 and solve for x, or I can say that, okay, 4x minus 4 and multiply that 2 over equals 44. A lot of times it's actually going to be beneficial for you to just double the median, and that's going to be equal to your two bases combined. Either way, in this case, you're going to get the same answer. X is 12, but do what you got to do. So then your last example here, given the isosceles trapezoid and the median, you're just trying to fill in the blanks. Again, going to be easier for me to think about it as 2x in here is congruent to 8 plus x plus 6. So when I combine those two bases, I get 14, x plus 14, excuse me, equals 2x. So that means that x equals 14. When I subtract the x across, it leaves me with 1x. So I can solve for x. I can also determine if that makes sense, because if the median is 14 and this bottom base is 20, 8 is 6 away from 14, 14 is 6 away from 20, so that does make sense. I always want to check my answers here and there. But then when I'm worried about angles, remember these two angles are corresponding to each other. They will be congruent, so 2 is 50 degrees. But this is literally a corresponding angle, considering all of these lines are parallel to each other. 1 is also a 50-degree angle, but 3, being one of those top angles, is not congruent to 1, 2, and that 50, but it's supplementary to those. So it's going to be 130 degrees. All right, so that's all the examples you need.